Good morning everyone. Myself Dr. Pradeepa SM, working as an assistant professor in Department of Chemistry at RNS Institute of Technology, Bangalore. So dear students, today I am going to take one of the very important topic under this particular CSE stream, right? So as you all know that, so our chemistry subject name in under CSE stream is applied chemistry for CSE stream. So having a subject code of BCHES 102 and 202. So 102 is for first semester and 202 is for the second semester. So dear students, so just for getting your curiosity, so I will tell you the name of some of the things. So just find out what are all these things, right? So just like that, like cloths, saucer balls, CD, DVDs, computers, glue stick, water bottle, plastic chair, plastic hanger, toothbrush, right, tiffin box. So all these things, etc, etc, etc. So, right. So now my question is, what are all these things, right? So can you use these things today? Have you used these things today? If not all, at least some of the things you have used, right? So they have become an integral part of our day-to-day life, right, in such a way that it is highly impossible to spend a single day without encountering it, right? So many of the people do not even know what are these things, right? They are using it, but they didn't know what are these things, right? The actual answer for these things so lies in one of the very important branch of chemistry, and that is called as polymer chemistry, and that is called as polymer chemistry. So these are all polymers and the things are called as polymers, right? So they are becoming an integral part of our day-to-day life, so much so that it is highly impossible to spend a single day without encountering it. So dear students, with that brief introduction, now you came to know the importance of these polymers, right? And you come to know that polymers are everywhere and they are widespread around us, right? So it is impossible to spend a single day without encountering that particular polymers. So with that brief introduction, let us come to this actual word polymers. So polymer, if you look at this word, so in Greek, poly means many, mer means unit. I will come to that a little bit later. So a polymer is a generic name given to a vast majority of materials of very high molecular weight, right? So the term polymer was coined in the year 1833 by Johannes Jacob Berzelius. Johannes Jacob Berzelius. So these materials exist in countless numbers and forms because of the more number of atoms and types of atoms are involved in these materials. See, the polymers exhibit different chemical structures, physical properties, mechanical behavior and thermal characteristics. So in Greek word, poly means many, mer means many and mer means unit. So that means that so many simple repetitive units have joined together to form a very high molecular weight compounds that are called as polymers, right? So if you can give an example for polymers, so proteins are the natural polymers which are synthesized by amino acids, right? Polyvinyl chloride are the polymers, right? So likewise we can give n number of examples, right? So in simple words, a polymer is a high molecular weight compound formed by the repeated union of simple low molecular weight compounds that are called as monomers, right? So now we have come up with one more important word, and that is called as monomers. Now let us see what are these monomers. By this time already you come to know that so monomers are the simple repeating units which undergo chemical union, right, and thereby they will form in very high molecular weight compounds that are called as polymers, right? So in Greek word, mono means single, mer means unit. In Greek word, mono means single, mer means unit. So these are the single repetitive units which undergo chemical union, right, which may become chemically bonded to another monomer, thereby they will form in very high molecular weight compounds that are called as polymers. So if you can give an example for these monomers, so amino acids are the natural monomers and polymerized to give proteins. So vinyl chloride is a monomer for polyvinyl chloride. Ethylene is a monomer for polyethylene, right? So these are the examples. So with this, under polymer, so we will come up with one more important term that is called as oligomer. So oligomer means, so they consist of finite number of monomer units. Usually that number will be varies between 10 to 100. The number varies from 10 to 100. If the monomer number units are in between 10 to 100, they are calling it as oligomers, right? So next important term one should know before entering into the actual concepts of polymer is degree of polymerization. In short, we can write it as DP. So degree of polymerization. So the word degree of polymerization can be defined as it is the number of repeating units present in an average polymer chain, right? It is the number of repeating units present in an average polymer chain. So that will give the degree of polymerization. So this degree of polymerization is having a relationship with the molecular weight of the polymers. So by knowing the degree of polymerization and by knowing the molecular weight of a simple monomer, that is a repeating unit, we can easily calculate the molecular weight of polymers using this formula. So molecular weight of polymer is equal to, so molecular weight of the single repeating unit, or it can call it as monomer, into degree of polymerization, right? So with this you can easily calculate the molecular weight of the polymer. Yes, so coming to the classification of polymers, so polymers can be classified into 4 different types. So the first type is, these polymers can be classified into natural and synthetic polymers. Polymers can be classified into natural and synthetic polymers. So this way of classification is based on the origin, right? So based on the origin, the polymers can be classified into natural and synthetic polymers. So those who are obtained from the natural resources, they are called as natural polymers, right? So if you look at the examples, cotton, silk, wool, rubber, etc. are the examples for the natural polymers. So coming to the synthetic polymers, so those which are extracted from these natural polymers or derived from these natural polymers, right, are those polymers which are synthesized artificially, right, using these available natural polymers, they are called as synthetic polymers, right? So examples for the synthetic polymers are, so polyvinyl chloride, polymethyl methacrylate, polyethylene, nylon 66, etc. Almost all the polymers are synthetic polymers, right? So those are the examples. Coming to the second type of classification, these polymers can be classified into organic and inorganic polymers. Organic and inorganic polymers. Organic and inorganic polymers. So this way of classification of polymers is based on their carbon backbone chain. That is, it is based on their backbone chain. So organic polymers are the one which consisting of carbon atom as their backbone chain, right? So those polymers which consist carbon atom as their backbone chain, they are all called as organic polymers. So the side valencies to the carbon atom is maybe atoms like hydrogen, nitrogen, sulfur, oxygen, etc. Right? So majority of the synthetic polymers are organic only, right? You can give examples such as polyethylene, polyvinyl chloride, polymethyl methacrylate, polystyrene. All these are organic polymers. So coming to the inorganic polymers, in inorganic polymers, the backbone chain is made up of other than the carbon atoms, right? The carbon atom is not the backbone chain. So say for example, silicone rubber, natural rubber or synthetic rubber are the examples for these inorganic polymers, which consisting of other than carbon atom as their backbone chain. So coming to the third type of classification, these polymers can be classified into thermoplastic and thermosetting polymers. Thermoplastic and thermosetting polymers. So based on the temperature, based on their behavior towards temperature, polymers can be classified into thermoplastic and thermosetting polymers. So now let us see what are these, right? So these thermoplastic polymers, so some polymers soften on heating, right, and that they can be converted into any shape, and that we can retain on cooling, right? So such polymers that become soften on heating and stiffen on cooling are called as thermoplastic polymers, right? So the process of heating and the process of making it soften and reshaping and retaining the same can be done several times, right? Several times. So that type of plastics or polymers are called as thermoplastic polymers. So examples are once again polyvinyl chloride, polymethyl methacrylate, or polyethylene, etc. are the thermoplastic polymers. So if you come to the other hand, these are called as thermosetting polymers. So these polymers, just like thermoplastic polymers, they also become soften on heating, but after becoming soft, they convert themselves into an infusible mass, right? They undergo some chemical reactions, and after that they will convert themselves into an infusible mass or insoluble mass that we cannot retain on cooling, right? So such type of polymers that soften on heating and that does not stiffen on cooling, or it cannot be reshaped or retain the same after cooling, so they will undergo some chemical reactions and they will become some infusible or insoluble mass, are called as thermosetting polymers, right? Thermosetting polymers, the examples are bakelite, urea formaldehyde resin, epoxy resin, phenolic resins are the examples for these thermosetting polymers, right? So remember, we want this information whenever we are dealing with Kevlar fibers, right? At that time we are saying thermoplastic polymer, we are using a thermoplastic polymer as a matrix, right? I will use this word while explaining Kevlar fiber, remember. So coming to the last type, so polymers can be based on their ultimate form and use. Polymers can be classified into plastics, elastomers, fibers and liquid resins. Right? So based on their ultimate form and use, polymers can be classified into plastics, elastomers, fibers and liquid resins, right? So coming to the plastics, see, polymer that are made up into tough and hard utility articles by the application of temperature and pressure, they are called as plastics, right? So we are very well known with this word plastics, right? If you ask any people, they will not know this word polymer, but they can say that plastics, right? Plastic is one of the type under these polymers, right? So the examples are polyvinyl chloride, polyethylene, polymethyl methacrylate, like that you can give an example for these plastics, right? The same polymer, if vulcanized into rubbery products, right, exhibiting good strength and elongation, right, then they are said to become elastomers, right? So elastomers, their vulcanization is heating the raw rubber or raw polymer using by adding sulfur containing compounds, right? If you heat that, so actually vulcanization is a process, it was invented accidentally, right, by Charles Goodyear, right? What happens when you heat a polymer with sulfur containing compounds, it will form sulfur-sulfur cross linkages, that's why it will give good strength and elongation to the polymers, right? And the polymers will become elastomers, they can easily stretch and they can come back and exhibit good stiffness also, right? So they are called as elastomers, right? So all the rubbers can be given as an example. So natural rubber, synthetic rubber, silicone rubber are the examples for these elastomers, right? Now come to these fibers, right? If the polymer is drawn into a long filament type like material whose length is at least 100 times greater than its diameter, then the polymer is said to have become fibers, right? The polymer is said to have become fibers. So the examples for these fibers is nylon 6,6, polyester, etc. are the examples for these particular fibers. And coming to the last type, so based on their ultimate form and use, we can classify a polymer into liquid resins, right? So like potting age, the polymers used in the form of liquids, right, in the form of adhesives or glue or potting agents, they are called as liquid resins, right? Examples are epoxy adhesives, polysulfide sealants are the examples of liquid resins. So this is the overall classification of polymers. So based on the type of the polymerization reaction involved during the preparation of the polymers, so this polymerization can be classified into two types. So one is addition polymerization. So first type is addition polymerization. So addition polymerization is a process in which the two monomer units or monomer molecules undergo a simple addition reactions. So without the elimination of any of the byproducts, and thereby they will form a polymers. And the corresponding polymers obtained through addition polymerization are called as addition polymers. That means that in addition polymerization, so the molecules will simply add on to each other, just like by the formation of a beads, right? If you are attaching a beads using a glue, just like that, in the form of a chain, they are going to undergo reactions, right? So that type of polymers are called addition polymerization. If you see the example, you can take ethylene as an example. So if you are taking n moles of ethylene, so then it undergo addition polymerization, thereby it is going to form CH2 n times. So this is ethene and this polyethylene, right? So like this. So the second type of classification is condensation polymerization. Condensation polymerization. So condensation polymerization is a process in which the monomer molecules undergo intermolecular condensation reactions with the elimination of simple byproducts such as water, ammonia, alcohol or HCl, etc. So thereby they will form a polymers, and the corresponding polymers are called as condensation polymers, right? So examples that we can take is nylon 6,6. So nylon 6,6 can be prepared by the condensation reaction between hexamethylene diamine and adipic acid. So if you read the reaction, so NH2, this is hexamethylene diamine, and CH2 4 times. Okay, you can write here CH2 4 times COOH and COOH. Right here, write N here and N here. So these two monomers undergo intermolecular condensation reaction with the elimination of the simple byproducts such as water. So thereby they will form nylon 6,6. So I will write this product here. So with the elimination of water molecules, there is n number of water molecules, right? So here if you write, so NH like this, NH, so CH2 6 times, NH, then C double bond O, CH2 4 times, C double bond O, En, right? So like this. So this product is called as nylon 6,6, right? So and the type of polymerization is called as condensation polymerization, right? So further, so if you are taking only one type of monomers and you are doing any of these addition polymerization or condensation polymerization, then that type of polymers are called as homopolymers, right? That means if both the monomers are of same type, then the resulting polymer obtained is called as homopolymer. And if you are taking two different monomers just like this, right, and the resulting polymer is called as copolymer, right? The name addition and condensation polymerization are relatively old type of names. So now people have given a new names for this addition and condensation polymerization. So now they have renamed addition polymerization as chain polymerization and condensation polymerization as step polymerization. So here chain polymerization is characterized by the self addition of the monomer units, right? So together, so without the elimination of any of the byproducts, right? and that are called as chain polymerization. As each monomers are simply added to one another in the form of a chain, so that's why we can give it as a name as chain polymerization, right? In case of chain polymerization, the product has the same elemental composition as that of the monomers, right? So that means the repeating unit will be similar to that of monomers only, right? So the molecules which contains reactive double bonds can undergo this chain polymerization. So that's why alkenes and substituted alkenes can easily undergo chain polymerization, right? So the examples using the chain polymerization, polyvinyl chloride, polyethylene, etc. you can give, right? So majority of these monomers which can undergo addition or chain polymerization are fall under vinyl category. So that's why chain polymerization is also called as vinyl polymerization, right? So the monomers are just like olefins, substituted dienes, right? So and then vinyl monomers are the examples. So that's why they are called as vinyl polymerization also. With this, I am going to explain chain polymerization. So chain means, as I already explained, it is the new name, that is the modified name which we have given to the addition polymerization. So I am going to explain addition polymerization only, right? Because the terms addition and condensation polymers are based on conventional classification by Carruthers, right? And they have been recently modified by HF Mark as chain and step polymerization. From here onwards, we are going to use that word chain and step polymerization for addition and condensation polymerization. See here, I will explain this chain polymerization by taking free radical polymerization mechanism as an example. So if you can consider free radical polymerization mechanism, so anyhow in this polymerization also it is having three steps. One is chain initiation, the chain propagation and chain termination, right? So in free radical polymerization mechanism, the first step is the chain initiation, right? So the chain initiation is brought about by the decomposition of the compounds that are called as initiators, right? Okay, so these initiators are thermally unstable compounds and decompose into products called as free radicals, right? So if R is a free radical and the bond formed between these two R's can be represented as R dot R, right? So then we can write like this, R dot R, right? Or else like R, right? We can take this initiator, we can write this initiator as it is, right, as like this. And if you supply a small amount of heat energy or light energy or any catalyst, so what happens, this initiator undergo homolytic cleavage and will form free radicals, each carrying a lone pair of electrons with it, right? Each carrying a lone pair of electrons with it, just like this, R dot, right, and R dot, right? So this is called as free radical formation by the initiator decomposition, right? So the examples, the most common example for this initiator is, which can be used in almost all the labs, right, for the synthesis of polymers are polymer is benzoyl peroxide, right? So benzoyl peroxide. So if you can see the structure of this benzoyl peroxide, so it will be like this, C double bond O, and C double bond O, benzene ring, right? So if you apply small amount of heat energy or light energy or catalyst to this, as it is an initiator, it is thermally unstable compound, it will readily undergo cleavage, that is homolytic cleavage, and will form two free radicals, right, each carrying a lone pair of electrons with it. So the cleavage can be shown like this, C double bond O dot, right? So this will undergo further decomposition at this particular junction, and thereby, so it will 2 moles of this one, and thereby it is going to form a free radical, that is this one, and 2CO2, right? And this only we can take it as R dot. So this step is called as the formation of free radicals by the decomposition of compounds called as initiators. The next step is chain initiation. Chain initiation, right? So a free radical is highly reactive and can attack any molecule which either has a lone electron or is prepared to part with one of its electrons, right? And that is called as chain initiation, right? So here I am going to explain this free radical polymerization mechanism by taking vinyl chloride as an example, right? So the free radical which is formed in the previous step, it is going to attack the double bond of the monomer, that is vinyl chloride. So that can be represented like this, the free radical R dot, right? So it attacks the double bond of the monomer unit, that is vinyl chloride, and its formula is CH2 double bond CHCl, right? So we can write this as vinyl chloride, right? So what happens is, see, the free radical site attacks the double bond of the monomer unit, and thereby it is going to transfer the free radical site from itself to the first monomer unit, right? And this can be written like this, CR CH2 CHCl and dot, right? So in this chain initiation step, so what happens is, so the attack of the free radical on the double bond of the monomer unit, initiating the chain, initiating the polymerization is an exothermic process, and the formation of free radical by the decomposition of the compounds called as initiator is an endothermic process. So overall, in chain initiation step, what happens is, the free radical, the active free radical, is highly reactive and it is highly unstable also. It will immediately attack any molecule which either has a lone electron or prepared to part with one of its electrons, and here I am taking vinyl chloride as an example, and thereby it simultaneously transfers its free radical site from itself to the first monomer unit. So next step is chain propagation, right? So the free radical site in the chain propagation step, what happens is, the free radical site which is present on the first monomer unit attacks the double bond of the second monomer unit. So as a result of which, the second monomer unit is going to add into the first monomer unit, and there occurs a simultaneous transfer of free radical site from first monomer unit to the second monomer unit. So through unpaired electron transfer process is going to take place. So that step can be written like this. So we have already initiated the chain initiation is already over. So we are now here. So that is RCH2 CHCl dot, right? So what happens? The free radical site which is present on the first monomer unit now attacks the double bond of the fresh monomer unit. So that is CH2 double bond CHCl, right? So thereby it will propagate the chain like this, CR CH2 CHCl, RCH2 CHCl, and this attacks the double bond of the second monomer unit. Thereby it will transfer the free radical site from first monomer to the second monomer through unpaired electron transfer process, right? So that's what we are writing. So CH2 CH and Cl. So now this attacks the double bond of the next monomer unit. So just like that, CH2 double bond CHCl, so like this, right? So this can be written here. So R CH2 CHCl, likewise CH2 CHCl, likewise CH2 CHCl dot, right? So this process involving continuing attack on the double bond of the monomer molecules, which in turn keep successfully adding into the growing polymer chain, is termed as chain propagation, right? So in simple words, this chain propagation can be represented like this. Instead of writing this very big structure, we can represent this chain propagation in a short way, like R CH2 CHCl, this is N times, and wavy line CH2 CHCl. So here N denotes this polymer chain consisting of N number of monomer units, and this wavy line indicates, so it is a polymer chain length of N number of monomer units, right? So this overall process is called as chain propagation. So the dear students, the next step is chain termination, right? So now we have seen chain initiation and chain propagation, and the last step in any free radical or any polymerization method is chain termination. So chain termination process, in this chain termination process the growing polymer chain will be arrested or it will be completely stopped. So it can be brought about by two methods. In turn there are two methods are there in chain termination. One is chain termination by coupling. Chain termination by coupling. So chain termination by coupling means here the two growing polymer chains, the lone pair of electrons which are present on the two growing polymer chains, so coupled each other, thereby they will form an electron pair and nullify their reactiveness. So and that method is called as chain termination by coupling. So that can be written like this. So here I am taking two growing polymer chains like RCH2 CHCl. So our general representation I am taking this wavy line CH2 CHCl dot. This is one growing polymer chain, and likewise you can consider the mirror image of this another growing part of this chain, right? So that I am going to write it in the reverse way, that is CHCl CH2 wavy line, so CHCl CH2, and here this time for the differentiation between the two growing polymer chains I will take R dot, right? So you can put N here and free radical site is here, right? So in chain termination by coupling, so the two lone pair of electrons which are present on the two growing polymer chain, they get coupled and form an electron pair. So thereby the two chains are going to become terminated, right? So here only I am going to show. So when the coupling occurs, so what happens? The two growing polymer chains are the free lone pair of electrons are get coupled and the chain termination occurs. So in chain termination by coupling, so as two growing polymer chains are coupled each other, right, by an unpaired by forming an electron pair, so we will end up with a polymer chain of bigger chain length, right? So this is one method. Coming to the second method, that is chain termination by disproportionation. Chain termination by disproportionation, right? So chain termination by disproportionation means here in this case, see the one of the growing polymer chain, what happens is one of the growing polymer chain obstruct a proton from the another growing polymer chain, and that proton will get paired with that lone pair of electrons which are present on the one growing polymer chain and it will get stabilized, and the other growing polymer chain which has donated a proton gets stabilized by the formation of double bonds, right? So that we can write here. So as you already know a growing polymer chain, say for example if this is growing polymer chain and this is another growing polymer chain, here in this case I have explained by coupling of these two lone pair of electrons it has formed a bond, right? So in this case, so what happens is, so this growing polymer chain, imagine I will write that, so RCH2 CHCl n times wavy line CH2 CHCl, right? So this growing polymer chain obstruct a proton from the another growing polymer chain. You just imagine this is as another growing polymer chain, or else I can write that, right, that CHCl dot CH2 wavy line, so CHCl CH2 R dot, right? So it will obstruct a proton from this carbon atom, right? So like this, and it will get terminated like this, RCH2 CHCl n times wavy line CH2 CH2Cl. So this chain will be terminated by obstructing a proton from the other growing polymer chain, and the another growing polymer chain which has donated a proton get terminated by formation of double bond here, right? So that I can show it here. So CHCl double bond, the free radical side will be going, and CH and CHCl CH2 R dot, right? and this process is called as chain termination by disproportionation, right? So these are the two common methods of termination, right? So like this, in the chain termination by disproportionation, we will get two polymer chain lengths of shorter chain lengths, right? Two polymers of shorter chain lengths, right? So like this we can prepare any polymer using this either free radical polymerization method if you are using a free radical, or if you are going for cationic polymerization method, then in that case R plus or H plus will attack the double bond of the monomer, and that is called as cationic polymerization method. And if R minus is attacks the double bond of the monomer, so then that is called as anionic polymerization method, or you can go for coordination polymerization mechanism, right? So usually that mechanism will be used for polymerization reaction between olefins and dienes, right? So this is all about free radical polymerization mechanism.